Welcome to our next installment of the How to Make PCB video tutorial series. Today I'll be showing you how to actually design the PCB in Kicad. Let's get started. So open up Kicad and I'll show you how to lay out your first PCB board. With Kicad open, let's first start by reminding ourselves what we'll be laying out on our PCB. So this is the circuit that we drew in the last tutorial video. It's just a simple LED circuit with a switch and a battery. Now you may have noticed I replaced the battery with a screw terminal. This is just for ease of use for this tutorial. But in the end you can always just connect a battery or 5-volt power supply, no problem. So let me first give you some background about a PCB drawing. You'll see that the PCB drawing consists of multiple different layers, each with a different name for a specific purpose. So for instance, if you look at this PCB, you'll see it's got quite a lot on it on the front and quite a lot on it on the back. And the manufacturer of the PCB needs to know how to manufacture it, and the different layers in our drawing actually communicate to them what holes they need to draw, what overlays they need to put on, what needs to be on the top, what needs to be on the bottom. So you'll see that there will be a specific layer, for instance, which will define the edge of the PCB. There'll be a separate layer which will define any drill holes that need to be done on the PCB. There'll be a separate layer for everything that needs to be on top, and there'll be a separate layer for everything that needs to be on the bottom. So this just separates everything and organizes it nicely so that the manufacturer can manufacture exactly what you want. With the schematic complete, we are ready to start laying out our PCB. So let's close the schematic and come here to the project directory and open up the -PCB file. And it opens up the drawing for us to lay out our PCB. Now you'll notice a few things. On the right hand side here we have all of our layers that we can draw on. Like I explained previously, they all have a particular function in communicating things to your manufacturer. Some of the important tools that we'll be using is obviously the select item, adding footprints, adding graphic lines, and also routing tracks. The first thing we need to do is define our PCB outline. This is done by drawing a shape on the edge layer of our design. So the first thing we need to do is come to our layer manager and make sure the edge cuts layer is selected. So anything we draw now will be on the edge layer. Come over here on the right toolbar and look for the Add Graphic Lines tool. Click it and just draw a line and click cancel. You can see this line is not very straight, but I will show you an easy way that we can draw a square without too much hassle. So come back here and select the mouse select item. Select the line you just drew and press E on the keyboard. This will bring up the properties for this line. And we will manually put in the length of the line that we want based on the X and Y coordinates. So let's say we want to make a 5 centimeter by 5 centimeter square PCB. Then let's make our line start on the X axis, that's this way. Start at 0 and end at 50 millimeters, which is 5 centimeters. And because it's a horizontal line, the Y can begin and end at 0 because it needs to be straight. And click OK. And you'll see the line has jumped up here. That's just because of the origin is over there for our drawing. But now it's been resized to 5 centimeters. So we can click and drag it onto the page properly. An easy way to complete our square is to copy and paste this line instead of having to manually redraw it the same way we just did. So if you zoom in and the line is selected, just push Ctrl+C on your keyboard and you'll see that it says select reference point for the copy. So this is quite handy. If you select the edge of the line, you'll see that a circle appears when you've reached the edge of the line. Click, and you'll see that it said selection copied. Now, if you push Ctrl V on your keyboard, we have a copy of the line attached to our mouse now. So if I push R on the keyboard, it will rotate. As you can see, the line is rotating. So let's go and complete our square like this. Zoom in a bit and you'll see that it's been copied on the edge of the line. So now I can easily go and place it onto the existing corner there. If I zoom out, you can see now we have two sides of our square. So let's just quickly push Ctrl V and complete our square. Push R to rotate. Zoom in to the end of that line and snaps into place. And voila, there we have our PCB outline. These are the components that I have selected to use with our PCB in this tutorial. So I've kind of laid it out here according to how we laid out the schematic. So we have our header, which we will plug in our power. We have our switch, which we will use to switch the LED on and off. Our resistor, just to protect our LED and control the brightness. And in the end, our simple LED. So I've chosen through-hole components, so we should be able to easily find some footprints that will match these. Now that we know which physical components we want to use, we have to now place the components onto the PCB in our drawing. And we call that a footprint for the component. So we do that by coming over to the right hand side and clicking the Add Footprints button, and then click anywhere on the screen. The first time it will take some time to load. But Kicad already has a library of commonly used footprints, so we should be able to find what we're looking for already in this library. The first component that we will search for is our header pins. Now I know from experience that these header pins have a pitch of 2.5 millimeters, so this is the distance between the two pins is 2.5 millimeters. So you see all these names have a P and a millimeter value next to it, so this is specifying the pitch for the footprint. So let's scroll down until we find the 2.5 millimeter one. This is 1.27, this is 2.54 millimeters, this is what we're looking for. And then we're looking for a 2-pin straight up. So this one is the vertical variation and this one is the horizontal variation. The component I have on my desk is the vertical one, so we select it and click OK. Next, let's look for our resistor. So, type in resistor in the search bar. Now you'll see the first category here says resistor SMD. These are SMD resistors, so they get soldered onto the board onto pads like this. Now our resistor is a through-hole resistor, so it needs to be soldered into holes that go through the board. So we call that a through-hole component. So we need to collapse that category and find the THT, the through-hole component category. Now you'll see Kicad already has a whole bunch that we can choose from. To speed things up, I've already selected the one that we need, and it is this one. Yep. You'll see there's also a vertical and horizontal variants. So to keep it simple, we just choose this one. And let's place our next component, and that will be our LED. So we type LED in the search, and once again you'll see the SMD category on top, but we're not dealing with an SMD LED. Now we're at the through-hole LEDs, and we have a very common 5mm LED. So there's the footprint for that, and we can select it and place it on our PCB. And lastly, we need to find our switch. This is a bit more tricky than the other components because it's not completely standard, but you just have to go through the footprints and see which ones closely match yours. So I found one that does, and it's this switch slide, but I need to double check that the hole distances, called the pitch, the distance between the holes is called the pitch. I need to check that that matches with the component that I actually have. So I went over here to find the drawing for that. That took me to this page, which is what the footprint is based off. So if I come here and click View Datasheet, it will download the datasheet, and I can have a look and see what the pitch is of this component. So this is the one we're using, and you can see here the distance between these two pins is 2 millimeters. Now if I go to the site of where I'm going to buy the component, or just to check the datasheet, this is the component that I physically have with me. I can open the datasheet as well, and I can scroll down until I find the one that I'm using. So I'm using the 90-degree one, and if I zoom in, I can see that the pitch is also 2 millimeters. In fact, this is the exact same component because the datasheets look exactly the same. So we know that our footprint will match the component we want to use. So let's click OK and paste it on the PCB. Before we can actually connect the components together and complete our circuit, we have to first tell Kicad which components belong with which symbols on our schematic. That way, Kicad will be able to help us in showing us which pins need to be connected to what. So we do this by renaming all the reference labels for all of our footprints that we place on our components. So you can see I've rearranged the footprints a little bit. This just makes it a bit neater. You can rearrange it however you want. There's no specific rules for a circuit this simple. I just put this switch on the edge of the board, considering it was a 90-degree switch, so it would be easier to switch if it was hanging off the edge. And the other components I just spaced out neatly on the board. Like I said previously, we need to rename these reference labels according to what the corresponding component is in the schematic. So if I resize this here and come to our project, and let's open up our schematic and do the same. Just resize it. Then maybe we can see both, and it will help us relabel. So we can see here that our screw terminal, let's get closer. Oh no. Okay, our screw terminal has not been labeled because I added it later. So if I quickly label that the same way we did previously, annotate, and we'll see that everything that I forgot to annotate has now been annotated. My bad. So now our screw terminal has a label, J1. So if I come here to our PCB and I have the select item selected, I select our footprint and press E like we did previously. There we go. And we'll see here there's a field called reference. So if we relabel this J1 and click OK. Right, next we need to label our switch, and that reference is SW1. Oops, don't double click. Highlight and push E. And here we call it SW1. Then we have our resistor, which is simply R1. So we name it R1. And lastly, our LED reference is D1. Now we need to tell Kicad that we are ready to link our two diagrams together. Once we've linked them, then Kicad will be able to show us exactly which pins we need to connect to each other to be able to form our circuit that we've drawn in our schematic. So to link the two together, we come back to the schematic, say Tools, Update PCB from Schematic. This window will pop up and will give some errors, but it's no problem. Just click this that says Reassociate Footprints by Reference. Then it will have linked them together and click Update PCB. Now our PCB has been updated, and now you can see that we now have these white lines connecting some of our pins together. So these are the indications of how we need to draw our tracks to connect this pin, for instance, to this pin. So now we need to just place our tracks and connect our pins together. To do that, firstly make sure that you are on the front copper layer, so this top layer here. Then come to root tracks. Now all you have to do is connect the dots, pretty much. So take your cursor and click on this pin, and you'll see that you start having a track attached to your mouse. This you can then bring to this track. There are some rules that you should take into account when placing tracks. One is that you should never create a 90 degree. Now you'll see that Kicad doesn't actually allow you to make a 90 degree track. So you don't actually have to worry about that. So let's continue routing our board. So you'll see here we have our nets that are crossing here. This is not very ideal. So let's select this component and rotate it. Then our nets are nicely on each side. This is much easier to route, and we like to keep things simple. So let's route this like this. And like I said, there's actually no actual rules to this, but everyone has their own style and likes to be neat. So I leave that up to you. If you find that there's a particular line that you don't like how it looks and you want to redo it, just highlight it with the Select Item tool and delete it. And then come back to the routing tool and just place it again. Let's see, I want to try and match this side a little bit. Oh, there you go. Let's clean this up a bit. That looks a little better. Before we finalize our PCB, we need to do a rule check to make sure that our PCB quality is going to be good. So some of these rules will include checking if you have forgotten to connect something properly, or for some designs the track widths need to be a certain minimum size or maximum size. But for this PCB we can just use the default rule checker. So to check our PCB, we go to Inspect, then Design Rules Checker. For now you can leave everything on default and click Run DRC. So I have a bit of a confession to make. At the time of recording this video, it was at this point where I realized that I had actually placed the incorrect header pin footprint. And the reason I had found this out was because of the rule checker. So the rule checker flagged us that we had our pads that were too close to each other, and I was like, but how? They're supposed to be 2.5 millimeter pitch. It shouldn't be flagging that rule. So when I had a closer look at the footprint, I saw that I had by mistake chosen the 1 millimeter pitch connector. So I went back and redid that part of the video of selecting the header. But if you notice the different header if you notice the difference header throughout the rest of the video, then you'll know why. My bad. So now if we do a fresh rule check with the new header, you can see that there's no problems or unconnected items. Let's also add some fun text to our PCB, because why not? So to do that, we want to work on the top silk layer. So this is the layer of the PCB which normally has all your labels and visible text and that sort of thing right on top. So we've selected our silk layer and click text, pop it on there. And let's type my first PCB. Smiley face. Okay, let's do it like that. And you can see the layer that it's on is the front silk screen. You can click OK. And let's just place it over there. Now comes the really cool part. Let's see our PCB in 3D. To do that, all you have to do is make sure your PCB window is active, and then on your keyboard press Alt 3. This will open up the 3D viewer. As you can see, it's busy rendering my PCB in 3D. And there we have it, the PCB we just designed in a 3D render. This is how it will look like in real life. And that's it. You've made your very first PCB layout. Join us in the next video where I'll be showing you how to take this PCB and order it from a PCB manufacturer. Also, everything that we've covered today you'll also find on the PlumPot website in our tutorial section. I'll put a link in the description of this video. If you're enjoying these video tutorials, then it would really be very helpful if you gave the video a like and hit the subscribe button to subscribe to our channel. I'm also interested to know what sort of tutorials you guys would be interested in getting from us, so you can also leave that in the comment below and I'll make sure to pick those up. And that's it for today. See you next time. Bye.